going through this narrows, I don't know, was the wind huffing and puffing? I don't think so. So I use it as resonance, but I don't think it is. So you could just use it as a standing wave, you know, wave traveling through, and that is a transverse wave, right? Now, okay, I want you to listen, and you can hear. Now, there's actually a lot of different frequencies. There's a screen on here, and the gas has to get pushed through the screen. And so what I'm going to do is, this pipe has nothing in it. It's one length, right? It's one length. And so what I need to do is pick something, some wavelength. It will automatically accommodate some particular wavelength in here so that we get a nice loud sound at the end. Not all of them. Some of them aren't going to fit just right. But that one does. Right? So what if I turn it over to the other side? Is it going to sound higher, lower, or the same? Same. What's funny is I could have said it like this. What if I lower this end and put this end now that's lower, and then people go, oh, it'll be lower.
Yeah.
You know? Yeah, it's fun. Okay, so, but you could get tubes of different length. And what if I had a longer tube? How would it sound?
Deeper.
Deeper, right. Okay, a couple reasons. I have more mass, and I also have a longer wavelength that it can accommodate. And the longer the wavelength, the lower the frequency and the lower the pitch. So I also use this as resonance, but I don't know if that's true. And I've asked a few people at the U, and they don't know if it's true either, because it, you know, is it resonating as the hot air rises up? You know, what's actually happening in here? I'm not sure.
I'm sorry.
Do it again?
Yeah.
Okay.
I don't understand how the heat is producing the wave. I'm not getting it.
Me either.
Convection. It's creating convection current.
What I know is I hear
The air
sound.
is moving through it.
Do you hear the sound? And I can pick up one of these sounds and amplify it. This is my sound amplifier. Because this has a certain length, and you know waves have a certain length. So this can only, you have to end up with an antinode up here, right, where the vibration is great so you can hear the sound. You don't want to have a node here. You want an antinode so you're disturbing the air in the room. And so only certain wavelengths can fit in here. And you want it to accommodate a wavelength where you end up with an antinode here. Remember, the antinode is where the vibrations are the greatest, and the node is where you hardly see anything happen.
So instead of picking it up, if you pushed it down, and
Yeah,
it's
go up and
longer,
down
would
with
you
It's
lose
not
it
going to be the right length for any
too?
of
You'd still
them.
lose the sound.
Just
Yeah.
that one.
Yeah.
Right?
Okay.
Besides cutting off the air.
Sure.
Right. So you can do this with a piece of PVC pipe and a 5-gallon pail of water. And you can tap the pipe and lower it, or hold a tuning fork. You can tune PVC pipe. I used to have them, and I don't know what happened. So you take the tuning fork and you hit it, and you have the PVC pipe in water so you can change the air column length. And hold it over the top, and in some places you will get a beautiful sound. I'll call it resonating sound, but I don't think that's true. And in some places you won't. So it just depends on the wavelength that can be accommodated in that tube length. Now there's a mathematical model that'll tell you which wavelength will fit in different tubes. And
You need to be able to put your arms